incentive that I promised, and I have a list already. Okay, what are we doing next?
Can we do
Yes?
one of the graph using transformations?
Yes.
To,
Yes.
I'll give you it's f of x equals negative square root of x plus 4, and then outside of it plus 1.
Excellent. So the base function that was used for this, obviously, is the square root of x.
Correct.
The next in line will be the square root of x plus 4.
Mm-hmm.
The next in order of operations will be negative the square root of x plus 4. And then finally, negative the square root of x plus 4 plus 1.
That's where I got her. Okay. I had two of them switched.
You need the negative
first.
yes.
Yeah, that's
yes.
where I went wrong because I had the x plus 4
So let me tell you.
first.
Let me tell you where does that come from. So if you want to evaluate this for 3,
Mm-hmm.
let's say, you will put 3 plus 4, but you will not add 1. You will have to multiply by negative 1 first, and then you add 1.
That's what I figured. I looked at it, I'm like, I think I got two of them mixed up.
So this is left 4. This is reflected with respect to the x-axis, and this is up 4.
Okay. Up 1?
Up 1, I'm sorry. I don't know why I wrote 1. Up 1.
Okay. That's where I got it wrong.
Okay, I would like us to write a couple of a list of topics, right? Ready? Yes? Okay, equations. Radical equations, quadratic equations, absolute value equations, radical equations. Did I say quadratic? I did, right?
So radical, quadratic, and absolute.
Right, and rational, right? Rational. Inequalities. Linear, absolute value, rational. Piecewise defined function. Difference quotient. Reading from a graph, right? Domain, range, max, min, increasing, decreasing. Reading from a graph. Graphing a polynomial or rational. Decomposing, what we just did a few minutes ago.
What did you say before?
Graphing a polynomial or rational.
And what did you say before that? Reading?
Reading from a graph.
Reading from a graph. Finding domain and range and x and y intercepts and max, min, and increasing, decreasing. Log and exponential equations.
Are inverses of each other.
Yes, they are. Very nice. Our favorite, Gauss-Jordan. The model that we just talked about. Garrett asked about that where we graphed it with the trajectory. So the model for quadratic. Some sequences. A growth model that will be given to you, like we had in the previous test. And systems to graph, linear or nonlinear. You have that on the previous test.
How many questions are on?
20 questions, something like that.
What did you say before the growth model?
Some sequences. So we do not meet on Monday. Today is the last day of classes, and we meet again for the final. Yeah, I will miss you too. I always, in my heart, I always root for one of the groups that I teach. Of course, they don't know that. You do. So I rooted for you. You are in my corner. Say it again.
What was the last topic after growth problem? Graphing linear and nonlinear.
Yes, graphing a linear and nonlinear system of inequalities. Right, solving systems of inequality, systems of equations, and graphing, and because we cannot solve in any other way the inequalities in two variables. We have to graph and shade in and the region. And again, I didn't show you examples of what. Why are we doing that? Because they cut off the next section, which is linear programming. So what we would do, we would get that shaded area, we will determine the corners, and we evaluate a function, a subjective function, or
And we don't get to do that?
no, they took it out. The objective function, sorry. The objective function is something that we want to maximize or minimize. And once we have the feasible area, we determine, we evaluate the objective function at particular values or points on the periphery, on the perimeter of the figure or the subjective of the feasible area, and those values will give us max min. Yes. Yes.
On the final next week, are the questions similar to the ones on last week?
Yes. Yes. I'm not going to invent anything. If I didn't do it in class, it's not going to be on the test.
They had all the solutions for the test on.
Yes. If you remember, we looked at them last time.
Yeah, you have both versions.
Yes, I have both versions. The last one was only one version.
Right, test for it.
Yes, and we have solutions. I would print out each version because they are blank, as well as and I think I do have a couple of the last test blanks if you want them. I have extra. Test 3. Blank. Test 3 blank. Test 3 blank. Blank, test 3. I didn't want to shred them or throw them away. Chris, you want them?
Friday, and I'll look at the idea.
What was the third one? That's the actual one.
I'm have to come here and just take my business one.
So you don't have to print it out, because I already have it. I have one more who wants the second one. Exactly. Which one? Number 3. Graphic is to the 4th minus 6 squared, okay?
Can we also look at these?
Oh.
Yes. So we are given a function which is x to the 4th minus x squared, is that correct? Okay.
That sounds good.
And we're asked to graph this function. It's a polynomial function. Immediately identify degree 4, turns maximum 3. I will find the x-intercept immediately with x to the 4th minus x squared equals 0 before I even start the table. So x squared minus 1, x plus 1, x minus 1. So I have to have 4 solutions. And that's how I know the multiplicities right away. So 2 zeros are 0. Multiplicity 2, turn. And then we have -1 and +1. Multiplicity 1, which means a regular cross. And now I have everything I need to start the table. And yes, this function happens to be symmetric. F of -x is identical with f of x even. If you plug in -x, nothing will change. So then now the table. It's polynomial, so obviously it has to be defined everywhere. I plug in -1, 0, and 1, 0, 0, 0, cross, turn, cross, and now I have to determine these. Well, it has degree 4. If it has degree 4, it has to resemble the end behavior of a quadratic, because it has degree 4, either this way or this way. Since the leading coefficient is positive, it will be this way. So it comes from positive infinity and goes back to infinity.
And that was a negative,
Negative to negative.
but if it's degree 3, it wouldn't.
If it's, remember, degree 3 resembles degree 1. Either this with a positive leading coefficient or this with a negative leading coefficient.
I'm sorry.
So much easier to explain. At the expense of looking silly. But that's okay. Okay, so negative 1 and positive 1 and 0, 0.
What you call mathematical charades.
Yes, my props. Okay, from positive infinity crosses at this point. Fine. It has to have a turn because it comes back and turns here. Now the rest I don't care, because what I graph on this side has to be the same on this side because the function is even. I don't even look at the rest. It's a waste of time to look at the rest. So I have to copy identical. They're not identical. I cannot ever make them identical. Perfect.
Close enough.
So this is f of x equals x to the 4th minus x squared. The only thing is that I cannot determine these min, which will also be absolute min, without a calculator. If you want to learn how, you have to take calculus. And you will see how we do this without anything. So clear x to the 4th minus x squared. And let's use the standard viewing window to see that this is, oops, sorry. That comes from Bailey, sorry. It's not my fault, it's Bailey's fault. Okay, yeah, so of course this is a lie, we know that. So I'm going to adjust a viewing window. Let's say between negative 2 and 2. And scale of 1 is okay. Y minimum, let's say negative 1, and Y maximum 2. It's crossing. Ah, yeah, exactly. So in order to determine this minimum, I know it's between negative 1 and 0. So with second and calc, I want a minimum, which is 3. And it's between negative 1 and 0. And give me the minimum. It's at negative 0.71. Negative 0.71. Negative 0.25. I refuse to determine the other one. Can anyone give us the coordinates of the other one? Say it again. There is no max. There is a local max at 0, 0.
The minimum's negative 0.70. Wouldn't the other one be 0.70?
0.71, comma,
20 or 25.
negative 0.25.
Negative 2.
Indeed, absolutely. And how do I know that? Because the function is symmetric with respect to the y-axis. Otherwise, I couldn't conclude that. I would have had to go back and determine the other minimum. But since it's symmetric, so the local max, 0, 0, local min, and also absolute min. The absolute minimum of this function is negative 0.25, and you can determine the range. Negative 0.25 to infinity. Very good. And then we wanted to look at the piecewise defined function. Any questions on this? Okay, perfect. So I would like us to make up a function, a piecewise defined function. We know so many functions now. We know exponential, we know log, we know linear, we know quadratic, we know cubic, We know radical, we know absolute value, we know rational. My goodness, we know a lot. Needless to say, we will be connected forever, meaning that if you need me for anything, even if I don't know or can help you, I will try to find the answer for you. So you can always rely on me. Sure, my pleasure. Our lives have crossed. And I'm very proud of you, obviously.
Oh, stop.
I am. I am. Okay, next, let's find a piecewise defined function. Yes, ready?
2x minus 4
Okay, 2x minus 4.
if x is less than 1. X squared plus 2 if x is greater than or equal to 1.
Excellent. Good. So you know why I don't really like this? Oops. It's because I use these symbols. That's the reason why I changed this into an interval notation, and I changed this into 1 to infinity because I will be using this symbol. So we see that the function is defined everywhere. From negative infinity to infinity, nothing is missing. There is no gap. To the left of 1, 1, and to the right of 1. So 1 must be an important point, or x value. There is a parenthesis opening to the left and a bracket touching an opening to the right. I like to write the functions above because they may be reversed. Who knows? To the left of 1, I will be using 2x minus 4. To the right of 1, I will be using x squared plus 2. I'll plug in 0. I get negative 4. I plug in 1, and I get negative 2. I plug in 1, and I get 3. And I plug in 2, and I get 6. Remember, this is a piecewise defined function. The two pieces cannot overlap. Be very careful. So 0, negative 4. And 1 comma negative 2 open. How do I know? It's a parenthesis. This is an open point. And it's a line. Now to the right of 1, I have to graph this. 1 comma 3, full point, and 2 comma 6. But I know this is quadratic. And if I were to graph the whole thing, it will be a terrible mistake. Because it has to start at 1 only. So this is our function. And I can also find a range. It's right here. From negative infinity to negative 2 with a parenthesis, union 3 to infinity. If somebody makes a mistake and continues with this function and continues with this function like this, it's this by vertical line test, this is no longer a function. So be careful. This piece is only to the left of 1. This piece is only to the right of 1.
How can we avoid making a mistake?
Say it again.
How can we avoid making a mistake doing 3 to 6? Just look at the inequality.
What do you mean by 3 to 6? Here?
Yeah.
But no, you're not graphing that. You're plotting 1 comma 3, and you're plotting 2 comma 6.
So basically, graph them from if you go by vertical, not horizontal, pretty much. If you can think about it that way.
Questions? Is this okay?
Can you make her down? No, down. Can we do inequalities, solving inequalities?
Yes. So any particular inequality you'd like to go back to?
I just have the one in the text.
That's fine. Whichever. December the 4th today, right?
Yes.
All day.
Almost Christmas.
Say it again.
It's almost Christmas.
Almost.
Don't, no, I don't want to hear anything about Christmas here.
Okay, ready? Final exam review.
Should take that. Yeah.
It was what?
St.
band
Nicholas's
is-
Day.
Yes, it is.
My friend's mom she lives in Germany and she sent her a care package for St. Nicholas's Day.
Yes, I called a friend to tell her happy birthday.
Yeah.
Her name is Nicoletta.
Oh, really?
Yeah, that's why. I guess she was born on the 6th. That's why. I'm ready. We have it?
Yeah. I don't do a different version. I want to do one I did.
Oh, I can pull it up.
We're doing solving inequality.
Yes, but I don't know which one, so. This one.
Probably the absolute.
Which one? Absolute value. Very good. So let's do that. So the absolute value of 1 minus x over 4 minus 5 less than or equal to 1. So obviously I have to clean it up by moving 5. Less than or equal to 6. And remember, when it comes to absolute value inequalities, we only have two possibilities, either in between or outside. And this is the in between, because it's less than. So the in between means -6 less than or equal to 1. I have to erase that. Less than or equal to 6. So it's in between.
How do you know if it's different?
Because you have to just read the inequality. You don't have to memorize anything. Just read the inequality. The inequality says, find numbers whose distance from 0 is less than 6. Where will those numbers be with distance? Where will they lie? They will lie between -6 and 6. If I have the opposite, then I'll say, where will I find numbers with distance from 0 more than 6? And they have to be to the left of -6 or to the right of 6, outside. So they have the distance between themselves and 0 more than 6 units. They cannot be in between. So if I want the distance to be less than 6, they have to be in between. So of course, I'm going to subtract 1 from all three sides. -7 less than or equal to -x over 4 less than or equal to 5. And of course, I have to get rid of -4. So when I multiply by -4, I get 28, I get x, and I get -20. You understand it will be silly to keep the same inequality symbol. If I tell you that x is a number that is greater than 28, but at the same time less than -20, how can a number be greater than 28 and at the same time less than -20? Right. So please remember we have to switch the inequality symbol because we divided or multiplied by a negative number. But now you have to read it from this side. -20 to 28. So careful with that.
Can we do a difference in quotient?
A difference quotient, very good. So let's come up with a quadratic function. And the difference quotient will be given to you. You don't have to memorize this. That's a difference quotient for any function.
just make one up.
Yes. So let's say negative 3x squared plus 4x plus 2. Good? Okay. Now, two pieces are known. One piece is not. This is known, this is known. But this is not calculated yet. So I have to find f of x plus h. And the pattern says negative 3 x plus h squared plus 4 x plus h and plus 2. You must remember that this is a trinomial. Please do not write x squared plus h squared.
The x squared plus 2.
Yes, 2xh plus h squared plus 4x plus 4h and plus 2. And now I have to distribute this. I have to. So this is negative 3x squared minus 6xh minus 3h squared plus 4x plus 4h and plus 2. So now all this will replace this piece. So then the difference quotient is, I copy all this instead of that. So negative 3x squared minus 6xh minus 3h squared plus 4x plus 4h and plus 2. Now careful, minus has to be distributed to three terms. So plus 3x squared minus 4x and minus 2. And we know that if terms without h do not cancel out, I'll say something is not right. Correct. And at the end, h, there is still an h left in the final simplified form, but not this one, unless I have had a hiccup somewhere. Okay, so look at these, look at these, and look at these. So the first step is good. We all terms without h cancel out. Now there are three terms left. They all have h in common, and that's how h goes away from the denominator. Negative 6x, negative 3h, and plus 4. So that's the final answer. Negative 6x minus 3h and plus 4. Anything else?
Can we do
Yes?
find the equation of a line passing through blah 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 when it's parallel?
Okay, yes. So give me a point and give me an equation.
Well, it's still working with the original problem perpendicular.
Yeah.
So the point
It would be a different equation, but yeah.
negative 2, 4, and the equation is 2x minus 7y plus 1.
Perfect. I still have to solve for y. Negative 7y equals negative 2x plus 5, or y equals 2 over 7x minus 5 over 7, because I need the slope of this line, which happens to be the slope of this line, because they are parallel. So now I will plug in everything in the point slope form. So I have y minus y1 equals the slope times x minus x1, where the slope is 2 over 7, x1 is negative 2, and y1 is 4. And I have y minus 4 equals 2/7, x minus minus 2. When I do this, again, I don't claim that my methods are the best. No. But I'm saying if I put minus minus, I have to write like this. And then parentheses outside, which is nothing wrong. But if I write it like here, yes, you can say, but this is the lazy way. It is. So x minus negative 2, then I can already write x plus 2 without dealing with that.
Nothing wrong with being lazy.
Well, I just trying to be funny.
What's smarter?
There you go.
So y minus 4 equals 2 over 7x plus 4 over 7. And then I have to bring 4 over. So y equals 2 over 7x plus 4 over 7 and plus 4. Remember, the least common denominator is 7. This needs to get a 7 because it's over 1. So 4 plus 28, 32. This is the equation of the line passing through the given point negative 2 comma 4 and parallel to the given equation.
Now, can I ask you a question?
Yes,
For the 30,
please.
would you rather have us leave it like that, or do you want
Yes.
to change it to a mixed number?
No, that's fine.
Okay.
32 over 7 is good.
For the type 1, type 2s,
Yes.
type 2s are.
The only difference is 0, yes. For type 2, the denominator is so much bigger and stronger than the numerator, and then the horizontal asymptote will be 0.
And if it was the same.
It's a horizontal asymptote, leading coefficient over leading coefficient.
And y would be 1. Or
Say it again.
what would y be?
That would be the y. Y equals, we had an example a few minutes ago. Leading coefficient over leading coefficient. Is it okay?
Yes. Graph a rational.
Say it again.
Graph a rational.
Graph of the rational function.
Yes.
This was just what you just did now.
Oh my gosh. It is.
That's of type 1.
Can we solve a rational equation
Yes.
or a radical equation?
Yes.
Although.
Yes. Trying to put the attendance in and I'm logged out all the time. Yes? Anything, please choose.
I don't have
Okay.
I'm ready. So we want a rational equation.
Yes. And radical.
Oh, actually, I'm here. I just put the attendance in. Okay. Is this one okay? Yes? Very good. So we have x plus 5 over x minus 2 equals 5 over x plus 2 plus 28 over x squared minus 4. Okay. So, yes, the restrictions, yes. So I have x plus 5 over x minus 2 minus 5 over x plus 2 minus 28 over x plus 2 x minus 2. I have to do this first, equals 0. So x cannot be plus or minus 2. Then I find the least common denominator, which is the product of the two. has to be x plus 2, x minus 2. And I need an adjustment here of x plus 2 and 1 here of x minus 2, and here nothing, or just write 1. Is this okay? Okay, so now careful how you distribute here because I have to use FOIL. So this is x squared plus 5x plus 2x plus 10. Now careful how you distribute negative 5 to these two terms. Negative 5x plus 10 and then minus 28. Now, yes, you can change it to proportion and cross multiply, but you also know that the fraction is 0 when? Exactly. So you don't really have to cross multiply anymore. So this is x squared, and this is plus 2x, and this is minus 8 equals 0. Or you put over 1 and you cross multiply, you get the same thing. So now the question is, can I factor? And the answer is yes, into x plus 4, x minus 2, and I get two options. And you have to say, not so fast, because you will never accept 2 because of the work you already put in. You already found the restrictions, or the common domain if you want. So you can't accept 2. Is that okay? Now we wanted to look at a radical. Oh, there is no radical here. Here it is. So the square root of x plus 13 equals x minus 7. Remember, the radical has to be isolated on one side, and it is. And please be careful when you square the right-hand side, how many terms will you get? Yes, please. Thank you. Excellent. So x plus 13 equals x squared minus 14x plus 49. How many times in the last 15 weeks we saw binomial squared? You see why I want to set the rules from the very beginning with that little thing? Because I don't want to talk about it again, if possible. Of course, if there is a question, I will answer it. But that's the reason why. So we don't have to overkill it. So this is x squared and then minus 15x and then plus, I think it's 36. Yes, 49 minus 13. And a negative 14 minus.
I'm sorry, I copied negative 49.
That's okay. Remember, in a binomial, when you square it, this term can only be positive. So now we're going to try and factor. What is it? It's x minus 13, x minus 12, and x minus. Yeah, I thought so.
You did the same mistake.
Yeah, see, I think so. History repeats itself.
Sorry.
So when we plug in 3, it's not going to work because the right-hand side will be negative. But when we plug in 12, we get 5 on the left and 5 on the right, so we will say yes.
Can we do a radical inequality?
Radical inequality?
Yeah, I thought that's what you had us write down.
We-
Also write down wrong.
No, we've never discussed a radical inequality. We don't know how to solve something like this.
Rational inequality?
Rational inequality. Yeah, for rational inequality, like say negative x plus 3 over x plus 2, let's say greater than or equal to 0. And this is x, negative x plus 3, and then x plus 2. We had something similar but with a product. And negative x plus 3 over x plus 2. So this is negative 2, and this is 3, and 0, 0. Yes, I know it's 620. Yes, so a negative 2 is undefined, and 3 is 0, so positive and negative. So it's negative, it's positive, it's negative. Greater than. But I cannot include negative 2, because it's undefined.
So it's parentheses 2,
So,
bracket
yes.
3.
-2, 3 with a bracket, yeah. Very good.